Hey guys, today we are talking about quadratic applications. And what really that means is we're just interpreting some graphs, okay? So we're using all the stuff we learned yesterday about how to find the axis of symmetry, the vertex, all of that, and we're just putting it into practice a little bit. So let's go ahead and remind ourselves um, how to find the vertex. And to start that, we're going to start with finding the minimum value. Now, minimum is going to be my vertex, right? But if it's a minimum value, that means my graph is going to open like this. And we're going to have a minimum at the bottom. And so we're just trying to find what that minimum point is. Now, remember to find the vertex, we first need to find my axis of symmetry. My axis of symmetry is going to be x equals negative b over 2a. Now, in this case, my a is 4, my b is 16, and my c is negative 3. So we're going to go negative 16 over 2 times a, which is 4. So 2 times 4 is 8. Negative 16 divided by 8 is going to give me negative 2. So the x portion of my vertex is going to be negative 2, but we're obviously missing the y portion of my vertex. Now, to find that y, we're just going to take my x, plug it back in for x, and see what the y is. So we're going to take my original equation, and I'm just going to plug it back in. So I'm going to go, okay, take this negative 2, plug it in for x here. So we're going to go y equals 4 times negative 2 squared plus 16 times negative 2 minus 3. Of course, you can use your calculator to help you with this, but let me run through it real quick. So we have negative 2 squared is 4. 4 times 4 is 16. 16 times negative 2 is going to be a negative 32. And so we have 16 plus a negative 32. That's going to be a negative 16. And negative 16 minus 3 is going to be a negative 19. So we're at my 2 points. My x equals negative 2. My y equals negative 19. So my 2 points are going to be negative 2, negative 19. And that's going to be my vertex, which means it's going to be my minimum. And we know it's minimum because my a is positive, so we're going to be opening upwards. All right? So there's our first problem. Next up, let's take a look here at number 2. So number 2, we have this graph. It's going to show the height h in feet of a small rocket t seconds after it is launched. The path of the rocket is given by the equation h of t equals negative 16 t squared plus 120 t. In other words, here's my graph of the rocket, okay? And so we're going to use that graph to kind of answer some of these questions. First question, how long was the rocket in the air? Well, this is time in seconds. So it hits after 8 seconds. So how long was the rocket in the air? 8 seconds. Like I said, all we're doing today is just interpreting a graph. Letter B, what is the greatest height the rocket reaches? Well, each one of these is 10, 20, 30, 40, 50, so it gets one above 250, so that's going to be at 260 feet. All right, and how many seconds does it take the rocket to reach its maximum height? Well, that's going to be my axis of symmetry, right down the middle, and that's going to be right at 4. So it takes 4 seconds to reach the maximum height, which kind of makes sense. 4 seconds to reach the maximum height, 8 seconds to reach back to the ground. Okay, about how high is the rocket after 1 second? Well, after 1 second, it's going to be at about 100 feet. Okay, after 2 seconds. After 2 seconds, it's going to be right about there. Okay, so after 2 seconds, it's going to be at 200 feet. Now, at that point, is it going up or going down? Well, at that point, it is going up. Okay, after 6 seconds. Well, after 6 seconds, we're back at 200 feet. This time, it is going down. All right, so we're just interpreting this graph. Okay, letter G. Do you think the rocket is traveling faster from 0 to 1 seconds or from 3 to 4 seconds? Okay, So let's take a look at how far it travels from 0 to 1 second. So from 0 to 1 second, it travels that whole distance. From 3 to 4 seconds, it travels that distance. So obviously, it's going faster from 0 to 1 second. Okay, last question here. Well, almost. Using the equation, find the exact value of the height of the rocket at 2 seconds. Now, this is where it gets a little interesting, okay? We're trying to find the exact value. And so we already had after 2 seconds, we said it was 200 feet. Now, we just need to find the exact value. To do that, we're going to take my original equation and I'm going to plug 2 seconds in to that original equation. So let's do that. Let's go negative 16 times 2 squared plus 128 times 2. Now, 128 times 2 is 256. The negative 2 squared is 4. 4 times negative 16 is going to give me negative 64. And then if I add these two together, it's going to give me 192 feet. All right, so our guess of 200 feet was pretty close, but we can find the exact time by taking my equation and plugging a point into it for that time. Okay, so my exact one is 192 feet. And then what is the domain and range of the graph? Let's start with domain. So remember, my domain is everything left to right. So we start here at 0 and we end at 8. Now I know I've said all quadratic equations are going to have a domain of all real numbers, but this is a real world example, which means I can't go forever in time to the left, forever in time to the right, really. My experiment starts at 0 seconds and it ends at 8 seconds. So my domain is going to be 0 to 8. Now my range, that obviously is going to have a very specific thing. We start at 0 feet. My rocket doesn't burrow into the earth. And we go to the highest point that my rocket goes to. And the highest point my rocket goes to is about 260 feet. So my range is going to be 0 to 260 feet. All right. So 0 seconds to 8 seconds, 0 to 260. So all we're doing is we're just interpreting these graphs. Let's go ahead and turn the page. Let's take a look at this one. What point on the graph represents the maximum height? So we have another graph, and so our maximum height is going to be here, and we're just going to guesstimate it a little bit. Obviously, it's at 3, and so we're going to say our maximum height is going to be 3, and then 16.5. 3 seconds, 16.5 feet. I mean, 3 feet out, 16.5 feet up. All right, what is the maximum height of her dive? Well, we just talked about that. It's going to be 16.5 feet. What point on the graph represents the height of the springboard? Well, that's going to be my y-intercept. That's where she started from. That's like the diving board that she started from, and that's going to be about 11 feet. Okay, so we're going to say 0, 11. How tall is the springboard? I'm going to say about 11 feet. What point on the graph represents how far she was from the springboard when she hit the water? So that's going to be all the way out here at 8, right? So that's going to be at 8, 0, and that's going to be a x-intercept. Something that I forgot to do. And then, so like this one, how tall is the springboard? That's a y-intercept, right? This one, the height of the springboard, that's my y-intercept. And then this first one, that is my vertex, the maximum height is. Okay, so then how far from the springboard did she dive? 8 feet. Okay, so look at number 4. Now we're into the fun stuff. Number 4. A rock is thrown from the top of a tall building. The distance d in feet between the rock and the ground, t seconds after it's thrown, is given by that equation. how long after the rock is thrown is it 310 feet from the ground? So let's first think about like my graph, okay? So like, I wish it would stop doing. So here's my graph, all right? And we start where it is thrown, okay? And we're throwing it from the top of a tall building. It's going to go all the way down here, okay, and hit the ground now. The distance d in feet between the rock and the ground, so this is d. This is my time in seconds. Okay, how long after the rock is thrown is it 310 feet from the ground? So somewhere around here, it's going to be 310 feet from the ground. And so I need to figure out when my distance is 310 feet. So what we're going to do is we're going to replace that distance with 310. So we're going to go 310 equals negative 16t squared minus 4t plus 382. And to solve this, I'm going to minus 310 to both sides, right? Because we still want to get 0 to both sides. And we're going to get 0 equals negative 16t squared minus 4t plus 72. And now we're going to factor out a GCF if we can. And my GCF here is going to be a negative 4. Because remember, we don't want my a to be negative. So we're going to say, okay, my GCF is negative 4. So we're going to divide this one by negative 4, this one by negative 4, this one by negative 4. So we'll have a negative 4 out in front times 4t squared plus t minus 72 divided by negative 4 is going to be negative 18. Okay, then we need to do my x and my plus. So I'm going to go over here and I'm going to draw my x and my plus. On top of my x, I'm going to go a times c, 4 times negative 18. So on top, I'm going to have a negative 72. On bottom, I'm going to have a 1. All right, now my two numbers, they can multiply to negative 72, but add to 1 are going to be 9 and negative 8. So we're going to have a 4t plus 9, a 4t minus 8. This first one cannot reduce. That's going to be my first factor, 4t plus 9. My second factor can reduce. We can divide both of these by 4 and get it to t minus 2. So that's my next one, t minus 2. So we're going to have 0 equals negative 4 times 4t plus 9 times t minus 2. We're going to set both of these equal to 0 and solve. So 4t plus 9 equals 0. T minus 2 equals 0. Add 2 to both sides, we get t equals 2. Minus 9 divided by 4, we get t equals negative 9 over 4. Okay, now only one of these can be my seconds, right? But remember, seconds are going to be positive. So it's not going to be this one. It is going to be t equals 2. So my answer to this question, how long does it take to get to this point? It's going to take 2 seconds. Okay? All right, so that's the easiest way to find my t for time. Let's turn the page. Let's do our next one. Number 5. A go-kart track has about 380 racers per week and charges each racer $35. In other words, here's my equation. We're trying to figure out how he can make the most profits. So he starts making quite a bit of profits, but we want to find what the absolute maximum profits he can make is. So to do that, we need to find the vertex. So what we're going to do is we're first going to find the axis of symmetry, right? Remember how we find the axis of symmetry? It's going to be x equals negative b over 2a. And so my b is going to be 320. So we have negative 320 over 2 times negative 20. Okay, so 2 times negative 20 is going to be negative 40. Negative 320 divided by negative 40 is going to be 8. Okay, so if he increases his profit by $8, okay, if he decreases the price by $8, he's going to increase his profit margin to the absolute maximum amount. Okay? So now let's find what that maximum amount is. So we're going to take 8 and we're going to plug it back in for my equation. So I'm going to go my maximum profit R is equal to negative 20 times 8 squared plus 320 times 8 plus 13,300. I ran out of room there, but you get the idea, 13,300. So now we're going to work this out. I'm going to plug this into my calculator, and I'm going to get my final answer of my maximum profit that he can make is going to be 14,580. Okay? So there's our maximum profit that he can make. So I'm going to write that out here. If he decreases the cost by $8, he will make a maximum profit of $14,580. Okay? All right. Last problem here, number 6. Number 6, the area of a rectangle is 560 square inches. Let's draw that out here. Here's my rectangle. The area equals 560 inches squared. Okay, the length is 3 more than the width. So here's the width. My length is going to be 3 more than twice the width. So twice the width plus 3 is going to be what my length is. If I take those two together and I multiply them together, it's going to have to equal my area. So we go width times 2w plus 3 equals 560. And then we can solve it, just like we've been solving our quadratics by factoring and all of that. So let's do that real quick. We're going to distribute. We're going to go w times 2w is 2w squared. W times 3 is going to be a 3w equals 560. Let's move this 560 over to this side. Make sure we write it in the correct order. Okay, now we factor and solve. First thing to factor, we look for a GCF, right? Well, this one has no GCF. Second thing that we're going to do is we're going to label my A, my B, and my C. So my A is 2, my B is 3, my C is negative 560. Then I'm going to draw my X and my plus. On top of my X, we're going to go 2 times negative 560 is going to be a negative 1,120. On bottom, we're going to have a 3. That's a big gap to make up. So we need two numbers that have a gap of 3 that multiply to the top. And those two numbers are going to be 35 and negative 32. Okay, so those are my two numbers. So I have a 2w, these two factors. So my first factor, 2w times 35. I mean 2w plus 35. My second factor can reduce. I can divide both of these by 2 and get a new factor of w minus 16. Remember, this is all just like we did earlier. Then we're going to set my two factors equal to 0, and I'm going to solve. So I'm going to go 2w plus 35 equals 0, and w minus 16 equals 0. So we get w equals 16, and w equals negative 35 over 2. Obviously, only one of these is my width, and it's going to be the positive one, right? So my width is going to be 16. So my width equals 16, and it's not going to be this negative 35 over 2. So then to find my length, we're going to take my width, plug it back in here. We're going to get 2 times 16 plus 3. So we're going to get 32 plus 3 is 35. So my final answer is going to be my width equals 16, my length equals 35. All right. I know this is kind of a doozy of a lesson. Just try your best. Make sure you ask me if you have any questions, okay? And really just think about like where it is on the graph and you should be just fine. All right, guys, so we have a great rest of your day.